we're going to talk about Docker and how to do it safely in astronomy. So just a quick word about my sponsors. So actually, this tutorial and my attendance here is sponsored by the Software Sustainability Institute, by the fellowship. So I'm a 2021 SSI fellow, and my job for the next, well, really year now left is really bringing some sustainable and efficient containers and practices around that to research, and especially for me, astronomy, because I'm an astronomer by trade, is close to my heart. So if you would like to collaborate, if you're interested in running any workshops, or you've got any interesting problems that are related to containers, not only Docker, I'm mainly focused on Docker Singularity, and recently going into the sort of venturing into a Podman territory. So if you've got any interesting problems, research problems, please get in touch if you would like to collaborate. I'm really open to collaboration. And yeah, we'll be using the tutorial GitHub repository and literally a terminal to run commands. So in the pre-tutorial document, there was a link to the GitHub repo. If you haven't downloaded it yet, please do. If you've downloaded it a while ago, it has changed. It might have changed a bit. So nothing major. So the most important thing that you will really need from that repo are the Docker files that we will use. All the text, I will actually talk about text. So it's up to you whether you want to also have it open on the site. I will be showing the text, so it's really up to you. So the text has changed. Docker files have not changed. So if you've downloaded Docker files like 2-3 weeks ago, they're still exactly the same. The text might be slightly different, but I will be displaying that. And I strongly encourage you to follow this tutorial. To try all of the commands on the terminal. Important thing is, let me know as soon as possible if you cannot run the Docker on your machine for whatever reason. I've got a number of virtual machines available, and they are available for the duration of the tutorial, plus an hour extra afterwards. But yeah, there is a limited number of VMs, and they take a moment to, yes, thank you for posting the link to GitHub on Discord. Yeah, and they take a moment to spin up. So yes, if your Docker is not working, please let me know as soon as possible in Discord, or send me a message, or reach me on Zoom. I think, yeah, Discord is the easiest way. But yeah, there is a way to go around if you find yourself stuck. As I said, just let me know as soon as possible, so we can get this running. Okay, so that's really the presentation, and as I said, everything will be in this sort of side-by-side view. I hope the font is big enough. Again, feel free to let me know if you've got some problems with seeing any font. I hope you'll be able to see it. But yes, feel free to ask any questions. There will be time, sort of logical within the logical flow, when there will be time for me to pause, maybe to go through any of the questions that are in Discord. But yes, feel free to ask any questions. I'll keep an eye on them constantly. If there is something really, really urgent, I will of course talk about it immediately. But yes, okay. So I'm not going to go too much through logistics. This is mainly for you if you go back to in your own time, at your own leisure, through the course. Mainly maybe just the logistics about who really this course is for. So the introduction assumes pretty much no prior Docker knowledge. So it's the weird sort of mishmash of difficulty levels, that it is based Mainly, I would say at the beginner Docker user or a beginner container user. So if you're coming from other containerization technologies such as Singularity or Podman, again, let's use that as an example. There is something here for you. But again, it's a bit of a weird mixture because I've got a feeling a lot of the Docker courses teach it in a way that they get you up and running fairly quickly, but they don't teach you fairly important things. So it's almost like if we were teaching Python and really telling you, how you name your variables is not important, when a lot of the Python courses from the very beginning, we tend to tell people, please don't call your variables X, Y, and Z. Whereas with containers, we just like, okay, just make it work. And so there is a bit of a mixture. So there is we're going to cover a very basic stuff in the first section of the course, but later we're going to go on a slightly more, I would call, a medium level concepts that I think are fairly essential as the title really of this workshop goes, to produce actually useful, efficient, and most importantly, safe Docker containers. So I hope everyone can see my screen. I don't know with the recording. I think with the recording, the green rectangle disappeared. It still says that I'm sharing the screen, but I'll just go and assume that the screen is still shared properly. Again, if you run into any problems, please let me know. So let's just talk quickly about what are really containers, and here it's I tend to distinguish between a container and an image. People tend to use these interchangeably. I put it incorrectly with a bit of a question mark. Because especially in the sort of usual daily speak, the line is very, very blurry. In this course, when I talk about a container or a container, when I talk about an image or a container image, I just talk it about as a collection of the software that you build up, bundle together, and it just sits somewhere on your disk. And then when you run this image, that becomes a container. And then you can rummage around the container, run some software, perform some operations as you would normally do on your operating system. So this is the kind of the distinction that I use. What I like to think about it, maybe that's not the best comparison, but I would like to think about it as the difference between a .exe file or any executable and actually an application that we run that, the executable sits there and until you run it, it's not really becoming an application really when you run it. We would still call it an application. This is sort of where the blurry part comes in. And what really are containers is that they can perform their work in really isolation. So you can think of them a bit like a virtualization. So later, what we're right now is that they offer virtualization like virtual machines, although slightly differently. The advantage is that you can have your entire development software stack inside your image, and it doesn't have to know what the operating system is up to. So you can do pretty much whatever you want within a limitation, of course, safety limitation mainly, but your containers, they don't have to have access to the same files as your host OS. You can make them do, or even share the same network. Again, it is possible to achieve that, doesn't come by default. So they are separate. So if you install software inside your image that's not visible to your host OS, you can do really whatever you want within this host OS. What they're really not, a lot of people say there are like virtual machines or virtual machines are lighter. I can see where they're coming from. I personally do not really like this comparison. One important difference is that containers, they do not virtualize the hardware. They do not contain a fully fledged guest OS on them. They do rely on your host OS. So the difference in there is a difference in the level of virtualization. If you would like to more details, there is a really, really good video and really good website by IBM folks that explain that difference. But we're not really, for the purpose of this tutorial, we're not really going to go into it. One thing is that there is quite a few misconceptions around the containers, and as I work on the containers and talk to people about containers and try to advocate the use of containers, more and more misconceptions really come to the surface. So after you attend this tutorial and you say, oh, containers are not really for me, or Docker is not for me, I want something else, I'm not going to be offended. That's absolutely fine. They're not one size fits all, and they definitely won't work for all of the use cases. So what they're really for, as I already said, I think the most important thing is that they do provide a reproducible work environment. And as we are becoming more and more aware about reproducibility, we're more worried about it. Maybe not worried, but we're more aware that this is something really, really important. And we really want to integrate it into our workflow. Containers really help you create this reproducible software. They go just beyond sharing your code. You can imagine you sharing your Python code or C++ code with someone through GitHub. You still have to rely on someone installing that code. Especially on C++, there can be a problem if there are different compiler versions of Python, if you've got mismatched, for example, NumPy versions or TensorFlow, that can cause problem. With Docker, you can provide not only your code, but the entire ecosystem around it, really. So you provide your Python code, but also provide all of the libraries, specific operating system, for example, if it's required. You can build self-contained images to meet the particular needs of your software. So you're not really bound to what's installed on your operating system. If you don't need development libraries because they're too heavy, you can include some lighter libraries inside your container. And as I said, you're no longer tied to software and library that is installed on your host OS. So just to give you a very practical example, in my day-to-day work, on the cluster that I work, we've got Python 2.7 installed by default because we have to, because there are certain requirements. But most of the software that I write in Python uses Python 3. And my colleagues that write it in Python 3, naturally, we use containers to have Python 3 installed in them and run our software in containers. Right, why containers might not be for you, and this is one of the most common misconceptions that I've seen. The biggest complaint that people often have is that people see different results on different computers, and they think that this is what containers are meant to prevent. No. Containers, as any software, containerized software as any software, can still give you different results on different hardware. Just to give you a most extreme example, running on a CPU versus running on a GPU, that code can give you sometimes different results. Containers do not prevent that. You have to make sure, as with any software, containerized or not, that you can cater and you can get correct results on different software architectures. They're not ideal for sharing large amounts of data. By that, I mean putting data inside an image. It is possible, but it's also possible in the same ways as it's possible to share big files on GitHub or on Git. It is possible, but you really wouldn't do it, would you? Or if you do, as I said, you can do it, and there might be use cases for it, but that's not what they really designed for. And as I said, you can still pack images, pack data inside your containers, but there are some limits. If you need to pack some machine learning test/train set, that is few gigabytes in size. And if it's really, really required, of course, you can do it. But there might be some better solutions. And yes, there are some safety concerns. So you can tell people, hear people say that they do not use Docker because of the safety concerns. And yes, even though I love Docker and I use it every day, there are safety concerns, especially one most commonly mentioned is the privilege escalation. We're going to talk about it later, but there are ways to mitigate that. And I think the main complaint might be that these holes, these safety problems, they are shipped to you as default, and you as a user, the burden is on you as a user to really secure your whole deployment. These section lengths are really just as a guideline. We can move some stuff around and skip some stuff around. So now that we covered, I'm not going to read all of the text through. It's really for you at your own leisure to read through it. But yes, we're talking about Docker here. I'm now going to be talking about different alternatives. And as I said before, if after this workshop, after this tutorial, you decide Docker does not work for you, I'm not going to be offended. I clearly have already seen some projects that I worked on that Docker might not be the best solution. So now I'm gonna, as I said, if you want, you can just listen to what I say and type me commands on the terminal. But what I would really encourage you to do is to type the commands together with me, and hopefully you're gonna get much more from that. But if you just here just to listen, maybe ask some questions, maybe you've used Docker before and you just hoping that you're gonna see something useful, please do that. But as I said, I strongly encourage you follow that. So yeah, as I said, I'll be showing what I will be doing on the right hand side. On the left hand side, I'll be typing stuff. So first, yes, as I said, I'm gonna assume that you have Docker installed by now and working. Again, if it's not the case, let me know as soon as possible. I can try and get you a virtual machine up and running really quickly, so you still get as much as possible from this tutorial. And as I said, ask questions. If you're stuck on something, ask questions, or even if it's possible, I think it's possible, interrupt me, unmute yourself, ask a question. I'm not going to get offended. It's better, I think, to get interrupted rather than you being stuck and hopefully, sorry, not hopefully, and possibly losing focus and falling behind. So we're going to run our very first command, and it's like a hello world of Docker images, Docker containers. Well, it's called hello world. So we're going to run Docker container run hello-world. And well, okay, so first command, I can already see some messages. First command give an error, unauthorized access. You can do it. So let me just go to installation. So I would ask you if you've got the unauthorized access, that's the common one. I would yes, you could either run it as a sudo, or if you go to installation procedures, and that's the thing that assumes that I'm going to go with Ubuntu. It's the same for all of them. I'm going to assume that you have a sudo access. So if you don't have sudo access because it's on your IT managed machine or university institute managed machine, the thing to do is to add your user to the Docker group if you don't want to run it as a sudo. If you can run it as a sudo, of course, as David said. So you should be able to run it as a sudo. If you don't want to run it as a sudo, quickly add yourself to the Docker user. The error is from Docker. Okay. So usually the unauthorized access is from okay. Okay, excuse me. So always teething problems. Docker image rm hello world. You can already see me spoiler, see some commands. Oh, F. Oh, come on. Just force it. Okay, image ms. Okay, Docker container run. I hope it's not what I think it is, because I had some. Okay, it's stupid thing. So I don't want to say it works for me. That's code unauthorized. Did you? So is that during the? Okay, Marcel. So we don't spend too much time on it. Let me. So because yeah, that's weird. Because that shouldn't use any username or password. I'm going to start a virtual machine if you're okay with that, and we could continue like that if that's okay. So for now I'm going to continue, and yes, hopefully it either resolves itself, and yeah, as I said, in the meantime I'm starting a virtual machine, so if the problem persists, okay. So yes, so we run the Docker container run command, hello world, and you can see that first it said it was unable to find image locally. So yes, for me it did work, and it gives you some useful information. It just tells you, okay, prints you some text, but what does this text actually mean? Where is it actually coming from? Well, we're going to examine it step by step. So one thing is that, the first command, the Docker container run, it instructs Docker daemon that we'd like to start a container using the hello world image. So the Docker container run tells Docker, I want to start a container, and then we tell it, use a hello world image. This command can also be run as Docker just run hello world, but I tend to use, and I do tend to teach the longer CLI syntax that's been introduced in 2017. I think it's more descriptive and it's less error prone, as we will later see. It is, you do type a bit more, but it tells you exactly what you're trying to do. So in this tutorial, I will be using the sort of longer commands. I'm mentioning the shorter version because a lot of people haven't made this swap fully yet. So you still might see the shorter versions. But in this tutorial, we'll be using the new one. So the next few lines, depending whether you've run the image before or not, you should see this. So if you haven't downloaded the Hello World before, Docker tells you that it hasn't found it locally, it will download it, and it downloads it from the Docker registry. If you, as you've seen it when I ran it the first time, it didn't tell me anything about a download. That means it found it locally, was able to find it locally, and it run from my local copy of that image. And the next few, yes, so that pool, that container run can really be separated into two different commands. So in this case, because we first download the image if you don't have the image, and then we run it. It can be really separated into two commands. So I can first docker pool hello world. Well, it's trying to download it. It says, okay, I already have it. And then I can separately docker container run once the image is downloaded. If the image is not downloaded, the docker container run will download it for you anyway. So it might seem a bit of redundant. Why would you do docker pull? Imagine you have an 8 gigabyte image. You're at work at a fast internet connection, not so at home. So you can download the image at work, and then when you're back at home, you want to do some work, or even if you don't have internet connection on a plane, you can still run the container based on that downloaded image that you've previously pulled. And the rest of the after is actually the most interesting part. Okay, great. That's actually the most interesting part, I think. That recipe tells you what's happening, and the lines 3 and 4 are the exciting ones. So line 3, the Docker daemon created a new container from that image, which runs the executable that produces this output you are currently reading. The Docker daemon streamed that output to the Docker client, which sent it to your terminal. So we didn't run any of the script that printed that message that wasn't run on your host OS. That was, image was taken, container was started, and inside the container, that script run and then printed that message to your terminal. The host OS had nothing to do with it except, launching the container. So now that we've run that command, we can do a couple of extra things. As I said, depending on whether you've had this image before, the first time I run it, it didn't tell me anything. After I deleted the image, it told me that it downloaded it. Docker knows that whether it has to download an image or a part of an image, or whether that image is already present on a computer. Can we have this knowledge? We can. By default, images are stored in directories with long names, very long names, associated usually with the SHA keys used to identify them. The length, this directory structure, where these directories are, that can be different between OSs and Docker installation, but there is a good command. That's docker image ls. And for those of you who use Nix operating system, Unix, Linux, Mac OS, the ls command should be quite familiar. Docker image ls lists all of the images. You will see a slightly different output to what you will get because, well, or depending how long you've been using Docker, if you've just run the command that we just run, you will see just one image. I will show you how the sort of more used a image sort of directory looks like. So if you run it, you should definitely see the hello world one. It is somewhere. It is here. We will later learn how to find them. But you can also here, let me make it bigger. This is what I have. This is what I've been working on. I've got quite a lot of stuff, like 6 different versions of CUDA, 4 different versions of Python, I think, some databases. So pretty much everything that I work on these days is inside a container. But yes, here is actually our hello world image that we run, and it's very, very small. But as I said, you can see something different, and yeah, the moment you start working on Docker, it can be pretty messy, especially, yeah, I'm like, what is this? So we can filter, we can definitely filter the output. If I'm looking just for hello world image, I want to know, say, its image ID, when it was created. I can just say, please Docker, show me images called hello world. So I type Docker image ls hello world, and it prints just the information about the hello world image. But for example, you do not remember exactly how the name, how the container was named. Some people in your team might be using hyphens, some can be using underscore. As you can see, I personally I'm teaching you about good practices. Some of my Docker images have a hyphen and some have underscore. Depends on, I think, which side of the bed I get up that particular day. So you can ask Docker, you don't remember. But you remember that it begins with something H, with hello, because it's hello world, but you don't know what follows exactly. You can use wildcards, and most I would call it reasonable wildcards. So a single character, group of characters, definitely a standard we'll see in a second. They do work. So I can again just say, instead of hello world, I can ask Docker image ls hello star, and in this case output is the same because I'm just printing the hello world images. But let me see if I've got anything that could be actually useful. Okay, yeah, let's do things that are that are tagged as my personal repository. So I can ask Docker image ls and Malenta, and you can actually see. Okay, no, okay, it doesn't take the. Yes, sorry. You have to be careful with the backslash. It's not happy with that. So yeah, I can match 2 images that are tagged as on my repository. Okay. So let's go back to the hello star. So what does this output actually tell us? Let's go through that. I mean, most of it is kind of self-explanatory. The repository that could be called image name, but if we're going to later learn how to push it to external repositories, that's called repository because it can have the name of your repository in front of it, as you can see here, or here with localhost 5050, and tag. We will talk more about tags later, but for now, think of them as like something to document a version of your image. So in this case, it's called latest because it's the latest version of that image. We're going to later talk about why this is really bad practice just to have your images called latest or use images called latest. Then image ID, which is a shortened version of your SHA-256 key. When the image was created, an important thing to see here that even though I've downloaded that image, it says it was created 4 weeks ago. The created time tells you how long ago the image was actually built. If you don't know what building means, we're going to talk about it in the next section, not when you downloaded it. And the last one comes size. Yes, so we've used the most basic version. Even such a simple command as image ls, as with, I think, Unix ls, there is much more to it. And this what we use here could work for you 90% of the time. But I strongly encourage you to visit the Docker reference, where in this case it's Docker images. It still uses the old syntax, but all of the options that are listed here you can use with Docker image ls. And yeah, so we run our image. We started our container. See, this is what I said. I find myself very often kind of using image and container interchangeably. So we run our container, and I can already see that there is also a mistake in the tutorial that should say currently running containers. If I want to be a stickler to the rules that I've just created. So yeah, we started our container. So let's see. Well, it should be running, yes. So Docker container in this case, not image, but container ls. And well, there's nothing running. That's weird. Well, we've just launched our container. What's going on? And there is really nothing. And what does it mean? That means that there are no containers running at the moment. And when we launched our Hello World container above, the container itself was designed to launch, do its work, and quit. So run this script that print the message and just quit and just finish, stop running. So it's just like fire and forget, just shoot once. Work is done, you launch a single script. Once the script is done, it's not waiting for any extra input, not running in the background, it's done. But that's how the design is decided. It should look, it doesn't have to. We have an option to check whether the container was started at all. So I can actually run docker container ls -a. Hello? Is someone unmuted because they want to ask a question? Because there was a massive interference as well. That's I think no. So we can actually run all of the containers, whether they're running or not. So in this case, again, you can see half of my work that I've been doing for the past months. But we can see at the top the Hello World container, and that it exited 14 minutes ago. So right after I run it, it exited. So in this case, we actually get some useful information. We know that we launched the container, it runs successfully because it exited with the code 0. You can see some others codes if your thing goes bad. In this case, this container, you can think of it as being hibernated at this stage, like you hibernate your laptop. It did its job, quit, but it didn't quit exactly. It's still there in the background, and you can actually still do things with it. You could restart it if you really needed to. And one thing, very important thing is every container, let me actually expand that. Okay, I can, right. Let me remove that for a moment. Yeah, that's slightly more useful. And maybe let me make it smaller so it fits on the one line. Hopefully everyone can see it. Yes, so again, like with the container, like with the images list, in this case, we've got a container ID. We've got information about which image we used to run this container, the command that was run, when it was created, the status, as I said, and important thing, a name. You can manage all of the containers just with the container ID, but it's very often easier to do it with a name. And when you run the container, when you start a container without any extra options, by default, Docker gives you a name, but it's a random name. My one is Laughing Vispervaraya. Your one will be most likely something different. If you've got something exactly the same, I would be terrified. If I remember correctly, there should be more than 65,000 combinations of these. But this can be a problem because Docker does it randomly. And when can this become a problem? When you're doing scripting, for example, and you would like to have a consistent name every time you run your script. If you run a database container, you want it to be called database, for example. So you've seen what I've been doing. I've been testing MongoDB, InfluxDB, running some Nginx. So I've decided to call them, test Mongo, Nginx. I should really get more consistent with the naming as well. As I said, it is fairly important, especially, yes, that's the first thing that we could talk about, reproducibility, that if you want to have reproducible scripts and don't want to rely on bash magic like grepping, awking, you have to name your container when you run it. And we do it with a name option. We will cover it later in the detail. But as I said, it's also useful, especially when you're running, because I had a discussion with some people a few weeks ago that are saying, that they're not really using name because they can distinguish what they're running from the name of the image that they're running. But say I can already tell you I'm running some web deployments that I'm running nodes, not Nginx, nodes images, and from that I wouldn't be able to tell just by looking quickly. But if you give it a nice name, you can tell it exactly what this container is doing. And also when you're removing the containers, so in this case, we're actually going to remove it. We're not going to keep it in this hibernation, that is this stickler in the background. I'm going to right now, remove it right now. So I'm going to use Docker container rm, and in this case, I will use a name that Docker gave me. You could very well use container ID, but this is sort of the same argument like with the names. The container IDs are random, really, same way as the name is random. So I could use this given name to remove the container. And now if I, question, what would happen if I run the Docker container ls, in this case -a, after removing properly that container? And I think the answer is fairly simple. If I do Docker container ls -a, again, we need to list all of the containers. This one in particular is gone because I launched multiple of them. So you can see that I had two of them. I had two, one Laughing Visvervaria and another one Hardcore Chebyshev. And now only Hardcore Chebyshev is left. So we can also, I don't want a Hardcore Chebyshev on my PC, so I can just say Docker container rm. In this case, I'm gonna use the ID. And again, Docker container ls -a. How many hello world containers I have? I have 3. Okay. Every time the one makes it to the top, I see a new one. So let me just remove it, Docker container rm, and let's just remove this one. But removing a container is not enough for me. I want to get rid of an image. I don't like it. I just want to get rid of it. So let me remove it fully. So docker image rm hello world. And in this case, I'm glad that I've missed it. In this case, what it tells me that it cannot really remove it because it is using, there is a container running that is using that image. And when I look at the list, I've launched so many Hello World containers that yes, indeed, there is another one that I launched 2 weeks ago, I think when I was polishing that tutorial, and I can force it. And I can actually force it to say, okay, well, this container is running, it's already running, still remove that image. You can force it, and the image is not gonna be there. The Hello World image is not there. And something interesting actually happens to the container. In this case, what happens is that the image, instead of being, where is Modest Williams? Okay. We've actually, no, so excuse me. No, we've removed that, Laughing Jackson. So we can see Laughing Jackson, before it was using Hello World. Now that this image reference is removed, it's just telling us, you know, it's just some SHA key that I know that existed, but it doesn't know. It doesn't know which image to connect it to. So in this case, when you see something like this, that means, yeah, that the actual underlying image has been removed. And yes, well, question, what happens now that we remove that image? What happens if I run this Docker container run command again? So if I run Docker container run again, the image is not there. And what happens again? Well, the image was not there. And again, it's pulling the image from the repository. It found some layers that it can reuse, but it pulls the image. So whenever you remove images, make sure that you're really not going to use them, so you don't have to keep on re-downloading stuff again and again. Okay, so far we've used this Hello World image, and Docker has been around since 2013, 8 years, 8 years. And there is an image pretty much for everything. We're going to talk a bit more later about Docker Hub. If you go on Docker Hub, there are more than 8 million images, and the number is increasing and increasing. So chances are that, especially when you're starting, you will find something for yourself. Say you work on machine learning, there is a lot of images that provide machine learning pipelines. But if you work in a very specialized field, or you've got very specific requirements, you might need to find yourself needing to create your own Docker image. And this is what we're going to do here. And this is where we are going to actually use the tutorial GitHub repository. So if only I remember Docker tutorial. Okay, so I am in the Docker tutorial repository. So yes, if you want to build images, I strongly recommend that you clone the repo. If you just want to follow, that's absolutely fine again. So let's just look first of all at the very first Docker image that we're going to use. So yeah, so it's okay. Let me just, it looks horrible like that. So this is your basic Docker file. This is very basic. I mean, you can do more basic than that, but I think that has some of the most important and most commonly used Docker file features that we are going to use. So the first line is really a must in your Docker file. It's the from instruction tells Docker which base image to use, and think of it as a basic scaffolding. Okay, there is a very yes, so there is a very interesting question, and I'm gonna answer it, Carsten, if you don't mind, after I go through the Docker file. Actually, let me answer that towards the end when we talk a bit more about Docker Hub, because that's a very interesting and very important question. So it's a must in your Docker file. And it tells you, as I said, Docker which base image to use. So think of it as a basic operating system that you throw inside your Docker image, and you install software on top of that. There are base images pretty much available for most popular Linux operating systems, or as close as possible to the image author. As well, if you want, there are now Windows-based images. And we didn't only tell Docker to use Ubuntu. I was very specific. I want Ubuntu 18.04. I didn't put just Ubuntu, because I could have just written Ubuntu like that. And in this case, as I said, Docker uses latest stack by default, but I was very specific. I want to use 18.04. And why that might be important? Well, because of the reproducibility. Say you've been working on some software, and you've been happily working on Ubuntu 18.04 or Debian or CentOS, and all of a sudden, if you only had Ubuntu, now the latest version is 2010, I think. Depends whether they by default support LTS or not. But yes, you cannot guarantee which version will be downloaded. One day it can be 18.04, the next day can be 18.10, the next day can be 20.04 or 20.10. And compilers change, default libraries change, network setup can change. So you can find yourself, even though using container, if you're just pulling from a latest base image, that something doesn't work once you rebuild the software after a year or even a few months. So my first bit of advice is, whenever you use a base image, be specific. Be specific to what you want to use and try to avoid using the latest stack. Next, we install some software. We change to the working directory, work the software. It sets the working directory for the following run and command instructions. Think of it as a CD with extra powers. If the directory exists, Workday will set it as a current working directory. If it doesn't, it will create it and then change to it. And then we actually do something that should be familiar to people using Debian-based operating systems, or if you're using CentOS, replace it with Yum. We actually install something inside our image. We install Git and clone the Docker tutorial. Excuse me, I need to have a drink. And then, what I do for readability, I tend to divide the commands into multiple lines with the backslash, and just tells Docker to continue on the next line, and you use double ampersand like usually on Linux to combine multiple commands together. And it's important, you will need working internet connection, but I assume since especially those, we're on Zoom, so you kind of expect you to have a working internet connection. And then we actually run the software. So the cmd instruction tells Docker to run this hello Docker script when we launch our container using Docker container run. So this is our recipe. This is only our recipe. So this is only our recipe, and we really don't have an image yet. So we actually have to build it. So what do we do? We use Docker image build command. Let me actually go to, so I can follow this fully. Okay. Oh. Okay. -L. I've just realized something horrendous, that I do not have the hello Docker script. Okay, we can still do it without it. It's just we're not going to get any results when we run it. So Docker image build -F. So in this case, I'm forcing Docker to use a specific Docker file. By default, it will use Docker file called Docker file. But I also tend to name them depending on what they're doing, maybe the version as well, just to keep even the Docker files documented as well. So because I'm in the root course directory, I tell it to use the Docker file from O to Docker intro, and then use Docker file O2. And then I use the tag. So the tag option actually gives your image a name. So I'm going to call it Docker. I always misspell Docker. Docker intro, and separated by a colon, I give it a tag. So yes, this option is a bit misleading maybe, because you first provide the name together with the tag option. You provide the name and give a tag, but the whole operation is called tagging an image. So in this case, I give it version 0.1 and a dot at the end, and that dot is important. This is not a typo. This is actually part of our Docker image command. Okay, that was a bad example. Why a whole context? Okay, what are we building? We're building our image. We are going for it, and yeah. Let me tell you in the meantime a bit more about the dot. It's, as I said, it's part of the Docker image command, and it specified the build context. That build context specifies files and resources that actually will be available during the build process. Just let me check something. Okay, no, I did not provide it, unfortunately. The beauty of live demos. It worked yesterday. Great. So that can happen, and we can debug it as we go. If you run into problems with the build, please let me know. Equals post. Come on. There we go. That should work. There we go. So if you run into this problem, for some reason, my network is all over the places. I've installed some VPN. If you run into this problem that it's bouncing back, there is a way of fixing that. We're not going to go through this through the tutorial. The way to go around it is specify network. Network equals host. Forces Docker to use a host network. And we're building right now. What's happening is we running that command when we updating, running update, installing Git, clone the repository, and hopefully everything is going to work. So now we actually build a Docker image. Because we're running a bit of short on time, let's not spend 10 minutes on that. There are three extra Docker files that are doing things slightly differently. As I said, I'm not going to run this particular image because I've forgotten to include the script for some reason. So well done me. But there is one important thing that I need to talk about, and so if we go together to the Docker02 directories, there are four different actually Docker files. So the first one, the Docker file 02, that's the one that we've just used. We run a command, we installed Git, we cloned the repository. That's it. The second one is actually A. So the second one, I mean, this is very basic, so let's not even run it. That's the minimum of the Docker files, really. Just a base image, and you can then take it, do whatever you want, and have really still a sort of like a separate system within a system. So we're not going to use that one. The second one, very similar, doesn't do much. Because that was an exercise. Oh, yes. And Docker C. So this is the one that I want to talk about. So so the other two were very basic, but this one is really the one that I really want to talk about. So I've installed Git, I cloned stuff, and then I got rid of Git because I really don't want it. I really do not need Git at this stage. Let's build that image. Let's use the command again, docker image build -f o2 docker intro. I'm already in that directory. Docker image build o2 docker intro docker file. What's going on? LSD is not found. Oh yes, docker image build -f, and then I say use docker file o2c, and then I'm going to call it tag. Well, I called it docker intro. I'm going to call it maybe docker intro version 0,2, and let's build it. Still don't understand. Yeah, so I've removed Git, and let's compare the size of these images. I removed Git. I want my image to be smaller. I want to get rid of it. I don't need it because I'm not going to use it, so I can create a smaller image. So docker image ls, docker intro, And did I use the, excuse me. Oh, this one is created, excuse me. Docker, did I create it with Docker into? Yeah, okay. Typo, yeah. So let's do in, yeah, there we go. Thank you so much, because I was like, what was going on? Thank you. I've removed Git and my image size increased. What's going on? Well, this comes from how actually Docker sorts out treats the run commands. Each separate run command. So here we've got two separate run commands. They're treated separately, and they just create an extra layer on your image. They don't actually modify things in the lower layers. They take information from the lower layer and add on top of it. So not only we didn't actually remove Git, Git is still there. You cannot access it. Yes, that's true. If you now run that Docker container, you cannot access it, but Git is still actually there, just hidden in lower layers. We've actually increased the size of our image because we created yet another layer on top of it. Why can this be a problem? Well, first of all, you're not removing software and not really decreasing the size of your images. The second thing is security issues. A lot of people build Docker containers that I've seen that they copy some sensitive data, for example, a password, into the Docker container in one layer and remove it in another. And they say, okay, I've removed the file I cannot access. No one can access it. That's wrong. Now everyone can access your sensitive information, your sensitive password, which is a massive, massive security issue. Now let's talk about this build context. I've mentioned this build context. What is going on with this? As I said, these are the files that are available, and so these are the files that are available in your. These are the files that are made available for your build. I will go to another directory because, yeah, my build context is now all over the place. And I'm going to build yet another file. And I'm going to run it. So I'm going to, do you know what? Docker image build -f. In this case, I'm in this directory. So I'm just going to use Dockerfile 02 tag Docker intro version 01 and use dot. And in this case, because actually I want to time how long it takes to build a whole image. And I've already built it, and I can't be bothered to just remove them. I can say no cache equals true, which means that Docker will not use anything stored in it. Some things that have been already created, and we'll just rebuild this image. And let's time it. Forgotten to run network equals host, so excuse me. Network equals host. That's not included in the tutorial because that was working. But as I said, my internet connection is all over the place. In the meantime, while this is happening, what we can do is when we are in this folder, when we're waiting on a build, we can create a file. We can create a 1 GB test file that we're not going to include it in our image. This is not going to be made part of our image, but will still influence. It will still influence our build. So yeah, I see there is some discussion about Docker security. We will talk about it in a second. So yes, it took 48 seconds. Previously it took 27. The internet is all over the place. It took 48 seconds. Now we've got this 1 gigabyte file. And as you can see at the very, very top of this command, if I go back up for a moment, it says sending build context to the Docker daemon, 17.96 kilobytes. Now let's look what happens. So let's take down now 48 seconds. Now I've created a 1 gigabyte file, and it actually sends the whole gigabyte file into a build context, which means it makes this 1 gigabyte of data available during the build time to the image. Whether you use it or not, it is made available. Because we don't copy it into the Docker image, that's not included in that image. The image size will not become much bigger. Here we might not see that much of a difference, especially I think the network issues will be more important. Thank you for extra 15 minutes. Will be more important. But yeah, we had 48 seconds. How much we're going to have now? It's taking its sweet time. As I said, the internet is that. Yeah, it took 58 seconds. Okay, we run it just once, but you can believe me, we could have already seen that it takes a while. Docker zips all of these files that are available. Now imagine that's just 1 gigabyte file, just 1 gigabyte file. Imagine you working on a machine learning project, and you've got tens and tens of gigabytes of data, and you've got Docker file in your root directory. Every time you build, you will be including all of your data inside your Docker file. I've been there, done that by mistake, placed Docker file in a directory that was 40 gigabytes in size. And then I spent God knows how much time figuring out why my relatively simple Docker build takes 2 hours to complete. So the best practice here is really trying to create a separate directory where you store your Docker file, keep your Docker file separate from your source file, any module files, definitely separate from the data that you don't need. If you do need to copy 1 gigabyte file inside your Docker image, you have to live with it. And you have to wait with that Docker. So yeah, we're already talking a bit about safety. So yes, so in this case, yes, when we look at the Docker image ls command again, and then you do Docker in. So yeah, I've built a couple of versions. So this one, the tags will be different. This one downloads just the base image. So this is just Ubuntu 60 megabytes, not much. Here we install the Git, download the GitHub repository, and here we install Git, download the GitHub repository, and remove Git. Again, as I said, it's not ideal. We actually didn't remove it. We've hid it. That might not seem like a problem, but as we already talking about a security, as I said, if you copy any sensitive data and you want to remove it, it has to be removed in the same line, ideally. So one of the ways to go around it, for example, is if I go, you can edit it yourself at your own leisure. You can test it. As I said, it's the layers that it's the separate layers. So there is nothing actually stopping me from doing in the same layer apt -y purge git. And here, believe me, the image will return to its original size, plus or minus a few megabytes, because Git leaves a lot of stuff behind, even after purge. But that might not be, maintainable. Another thing is, you can say, oh, that's just Git, that's just 100 megabytes. These things add up. 100 megabytes here, 100 megabytes there. You install 30 packages, all of a sudden you have 3 gigabytes. That's a lot. So yeah, here we talk about a bit how to reduce the size of the images. The first thing, as I said, install really what you need. Installing Vim inside your image might not seem harmful because it's what, 60 megabytes, 30 megabytes? But multiply it, as I said, 50 packages, that's multiple gigabytes. Installing a debugger, just in case, well, that's a couple of gigabytes, depending on what you use. That can be useful. In this case, if you need that, it's always good to maintain a test environment and a production environment, or a development environment and a production environment. So that production environment really has stuff, only the things that you need to successfully run your pipeline and nothing else. The requirement is also important when using base images. Here we use Ubuntu 18.04. There are many, many, many more base images. The one that I use very often is CUDA base image for GPU computing. And if you look at the Docker file for their CUDA base image, the development image contains pretty much every single CUDA library you can imagine. And I might not need it. I might not need 5 gigabytes of libraries, half of them machine learning, that if you just run some custom GPU kernel, you might not need it. What I personally do is I download just the most bare bones CUDA image with just the drivers and then install things I need on top. And you might need to do it as well, that try to find the most basic image that you have and then install just things on top of that. Because especially the development images, a lot of the development images, especially in C++, come with development libraries, which are much heavier and are necessary for the compilation, but you might just as well use write-time libraries. So one thing with the security that improves the security at the build time are the multi-stage builds. So with the multi-stage builds, you can actually separate your build into multiple stages, and one doesn't have to know, the right hand doesn't know what the right hand doesn't know what the left hand is doing. So we can look at one of the Docker files. I've got, the multi one. So in this case, I have, well, what is the main thing about the smoking gun of multi-stage build? You have 2 from commands. And in this case, I have first one, which really gets the base image. And I name my stage. I name my stage downloader. I do the stuff that I was doing before. So we create a software directory, install Git, copy the Docker tutorial repository, but then I create another stage. In this case, again, I use Ubuntu 18.04 image, which starts another stage, which is just a blank sheet. Whatever happened here is not included automatically in that stage. And in this case, I create yet another software directory for this case, in this case. And only then I say, from stage that I called downloader, download the data that I need. And the only data that I need is Docker repository that I pulled. And that pulls only that. Git is not included. Whatever I did with update is not included. So benefits about what we talked before. You can, well, still, you shouldn't store passwords in your Docker files, but you can already start putting maybe some credentials if you really have to over there. You can use development libraries in your, for example, builder stage. You can call it builder stage and copy only the executables and install some extra runtime libraries in your second stage, and only your executables and your extra runtime libraries will be included. All of the compilers, all of the compilation libraries, they will stay in the previous stage. They will not be included in your final image. So let's not talk. Let's not talk about it. We can actually build it. So yeah, Docker, again, Docker image build. I'm going to force the O3 Docker file O3 multi. You mean including, so yeah, there is a question, what if you don't need the Git there for the whole coding history track? You mean included in the image or just in general? I mean, if you don't need it for the whole coding track, feel free to remove it. In the image, yeah, you could just, yeah, I would say you could just remove it. Oh yeah, I think I understand it, inside the image. Yeah, I would personally just remove it. I always do use the history track, or yes, you could copy just the relevant data. Here in this example, I copied the whole directory. You could copy just the relevant files. So for example, as I said before, if I was building a C++ code, and of course I would download the Git repository and have an executable. After that, I will copy just the executable from the inside the directory that I was working on. So yes, in this case, in this file, we do copy the whole repository. But yes, I do understand that copying the whole .git file might not be necessary. You can just copy. You can just copy, you know, whatever you want. You can just copy a single directory. Okay, there are some questions, but we need to press through. So I'm gonna look through them later. So we can build that image force and then tag. So Docker intro in this case, and let's call it VO3 after section 03, and then tag, yes. And I'm using a massive build context. So this is an example of why you should clear your build context. So in this case, yes, we're using image cache. So this is the thing. The previous commands, as you can see, run really, really fast because it tells you it's using cache. It's using cache. We've built that before. Docker is fairly intelligent. If it sees something that you've built before, it will go and say, I've seen that before, let me reuse it. And if I do the command again, it better be, after the multi-stage build, I'm back to pretty much the original file size. It's slightly bigger because, yes, there is this repository inside, but I don't have Git and associated stuff with it. Yeah, it says 30 minutes, but yes, let's just quickly talk about, maybe making Docker data available inside the container. So there are two ways. We've seen one of them. So there's the copy command. We can copy the data inside a container, inside an image that makes the data part of the image. And I'm not going to build it because it's going to take a while, and we're definitely not going to do it as an exercise. if I create a 1 GB file, copy that inside my image automatically becomes larger than 1 GB. That might not be an option. You can be on a system that there is a limitation on the image size. If you have 30 GB of data, you might not want to include it. So what you can do, instead of copying it, you can actually make the data available inside your file. And in this case, oh, it jumped, lovely. And in this case, we use so-called bind mounts. So with bind mounts, you essentially bind, and we're going to use the most basic option, bind mounts, which essentially mounts the data from your host machine inside your container. So what I can do in this case is I can do docker container run. We haven't used that command for a while. -rm. I use -rm, so I don't have to do docker container rm. It cleans up automatically. Mount, and in this case, I use a very verbose syntax. And there is a shorter version. This is, again, fairly new, 2017, quite verbose, but much more descriptive, less error prone, and actually works with UTC times. Type equals bind, so I tell it to use a bind mount. Source equals, I want a PWD. So you can specify either hard-coded path or just, print working directory. Okay, in this case, yeah, do you know what? Let's print working directory. Let's do quite a lot of that. And target equals, do you know what? I want this to point in my software. Maybe not software backup. And then I can write a command. So let's first say which Docker image, Docker intro. Let's run the final one, VO3, and then ls-l software backup. What did I break? Key target, yes, target. Oh, jeez. Yeah, good. Okay. Oh, there we go. Right, I shouldn't have put it in the commas. So yeah, so I've got actually my host directory, and I can access it from inside the Docker. Important thing to remember is that doesn't create a copy. That just mounts the data inside a container. So if you change the data on the host, that will be changed inside the container and vice versa. So if you remove all of the data from inside your container, that will remove all of your data from inside your from your host OS. And yeah, I think that was already mentioned. That's a bit of a security issue, because imagine I've mistyped a lot of commands today because, a bit of a stress, haven't taught that course for a while. I do something really bad. let's run something first of all as an interactive user. So -it, so we can rummage around the container. Again, let's remove it automatically, and let's run docker intro version 03. Now I'm inside the container. Okay, someone can already see a problem, and that was mentioned on the Discord channel. There's one massive problem, and it's a huge for Docker. And yes, I personally do understand, even though I do like Docker, I use Docker, that yeah, you're a root inside the Docker. This is a problem. This is a privilege escalation that even as a non-root user, when you run Docker inside with default parameters, you are root inside. And that can be problematic because, as I said, I make typos, I make mistakes. And please, I cannot stress it enough. This is my PC. If I break it, that's fine. Please do not execute the next command. Okay? Let's say I mistyped something and I've used / as my source directory. And as I said, please, please, please do not execute this command at all. Let me do it just to show you. So I changed to software backup, and I have access to, as a root user, I have access to my root file system on my host OS. So yeah, so it's a bit of a problem because yeah, I've made a mistake, and you know, I've realized it, that I've made a mistake. But hey, you might not have realized that you've made a mistake, and you run rf minus rf, rm minus rf. Or you did have a malicious user that started this container maliciously. So as I said, I do not take responsibility for running that command. And I can do stuff. I can do stuff here. Again, do not do it. This is at my own risk. Touch hello.dat. And I've created a file. Whereas if I go to the root directory just as me, and I tag hello2.dat, I get permission denied. So already that allows me to do things I should not be able to do. There is again, this is Docker by default for you. And as someone posted an excerpt from the reference is the Docker containers are by default safe, quite secure. I would disagree with the by default part because this is by default. By default, you run as root. But if you run as a non-privileged user inside a container, that can stop this from happening. So a very simple thing already to prevent it, and what you should definitely do whenever you launch a Docker container, we can do it inside the build file, inside the Docker file, set up users. But yes, if you download a container, especially from a Docker Hub, you might not have access to the source code, you might not be able to change it, but you still need to run it, and you still need to change user. You can set it a user. In this case, yeah. So in this case, I'm gonna set it up to myself. You don't need to run this command, especially if you don't know your user ID, because Docker, you have to provide a Docker user ID, and then I separate it by a group ID. Oh yeah, mount user. Yes. Typo. As you see, typos everywhere. Typos everywhere. User thousand. So that's me. Once you logged into once you're inside the container, yeah, you will see cannot find name for group ID. I have no name because even though Docker shares group IDs and user IDs with the host OS, it doesn't know actually the username for that. But 1000 is not a root. That's me. I know that 1000 is me. Just a regular guy, you know, from a regular place without root permission. So if I go now to software backup, and if I try to do touch hello 3.dat, again, I get permission denied. So even though I've made a mistake and I mounted my root host OS directory to inside Docker container, I cannot do damage. And this should really make sure you never, ever really, especially the Docker containers that you download from Docker Hub, never run it without specifying non-root user. If you really, because you shouldn't really need to run as a user inside the container. And if you, so this is definitely that I do, this is what my team does. Your mileage may vary. If you expect to run Docker on a regular basis in production environment, as a web server, real-time processing pipeline, please consider creating a separate user on that machine with privileges limited to just what you want it to do. So run Docker and not much more on the host OS, so that when you make a mistake, you cannot do damage. And now we're coming to actually, well, something that is kind of a safe mode for Docker. We're not going to run any commands, but I throw it so that people are aware. Docker introduced a so-called ruthless mode. So running a standard Docker daemon, running all of the Docker commands requires root privileges. And unless you're in charge of your software, you may not be able to install it on your own. And IT, quite understandably, because of the situations that we said, might not be willing to do this to you for you because of various concerns. But with the most recent version, Docker offers a rootless mode. And what it does is that you don't run it as a root, and your Docker images, your Docker containers are fairly limited. They come with some limitations that, for example, you can no longer use privilege ports, which are numbers less than 1024. That can be, yes, I'm finishing quickly. It's still possible to expose them with absolutely necessary if you want to, for example, run a web server. But yes, you have to put actually some legwork into that. And by default, rootless mode provides you a fairly, I would already say, a limited Docker daemon. So even if you have root privileges on your machine, consider running Docker in rootless mode. If you don't require any advanced configuration, that again separates that again the inner components of your OS from your host OS. So yeah, and then yeah, we talk about Docker Hub. Yeah, we're running a bit out of time, so I'm not going to talk about. Yeah, well, you can look about how to distribute images on the Docker Hub. But yes, there was a question. Yeah, there's definitely a lot of talk about security. That yeah. So how can you run Docker images from Docker Hub? In this case, provided by someone with regard to cybersecurity. Yes, bad stuff can be put in. But on the other hand, if you don't do anything, I would say, at least from my own experience, if you don't do anything super bad on your site when you launch the container, so expose the root directory, give your running container too many privileges, this damage will be contained to within your container, unless of course you mount some data and the script is specifically designed to find some data inside a running container and erase it, and you lose 40 gigabytes of data, then yes. Whenever you, with Docker containers, it's pretty much like with any software. You do have to be careful with who downloads what. I'd say I would apply the same sort of security principle as downloading, any pretty much GitHub repository, that I would not necessarily trust every GitHub repository that I download, and I would think twice before running all of the code inside the GitHub repository, from the GitHub repository. The same, I would say, applies to the Docker images, or really any software, that you download these days, even from trusted sources. There are, however, Docker Hub images that come from trusted sources, that are verified, secured. So, for example, Python distributions, Ubuntu, all of the operating systems, they are verified, and they're definitely secure. Okay, there is still some other stuff that I want to talk about, but yeah, we run out of time. As I said, is there any way to sign Docker images? As far as I know, the regular understanding of signing, no. They all have the SH, well, they digest the SHA-256 key. So your image is kind of signed through the key. So if you've got an image that well, that's pretty much, I would say, as close to signing as you get. You've got the key, which identifies the image, and if someone makes a change to that image, the key will of course change for that image. So if you download an image and it's not, but yes, signing in terms of like certificates and stuff like that, I personally do not know. Yeah, or maybe there is. Yeah. Oh yeah, they are. Yeah, I personally haven't used that. So yeah, what I've been personally just using is just the sort of trusted images. But yeah, if your security requires, you can use the signed ones. And I think, yeah, we did run out of time. Run over. So thank you very much. If anyone has, yeah, we could discuss about Docker and whether to use it or not for ages. But if you've got any questions or suggestions, please get in touch with me, and I'm happy to discuss things. Thank you very much to everyone attending as well. Thank you.